Welcome back. And in our previous lesson, we used the K nearest neighbor classifier to output a prediction of the Wisconsin breast cancer dataset to see if a tumor was either benign or malignant. In this lesson, we are going to use the logistic regression classifier and work with the same Wisconsin breast cancer dataset to look for a binary answer that represents a benign or malignant tumor. Logistic regression is counterintuitive given that it is a classifier and not a regressor, despite its name. The difference between classification and regression is that classification outputs categorical data, like a binary classification or a Boolean classification, whereas regression outputs continuous data, like stock prices or income. So in this lesson, we are going to use logistic regression to see if we can improve the prediction output from the breast cancer dataset. So first, we need to call the dataset from scikit-learn and load the dataset. So next, we are going to import the logistic regression model from scikit-learn, as well as the train test split model from scikit-learn. Then we'll import matplotlib, and then we will instantiate the dataset. Next, we'll train test and split the matrix. Next, we'll instantiate the logistic regression classifier and fit it to train. So we'll run this to see the default values for the logistic regression algorithm, be it the class weights, the booleans for dual, as well as the fit intercepts, etc. So here we can see the default parameters for the logistic regression algorithm. Next, let's print out the accuracy for both the training and test subsets. And we'll run that. And so we have a 95% accuracy on the training set and 97% accuracy on the test subset, which is a significant difference in real time, and it shows a more efficient prediction using the logistic regression versus the K nearest neighbor classifier. We use something called regularization, and in regularization, it prevents the overfitting of a model. By default, regularization uses the L2 or L1 assumes only a few features are important. And the parameters to control the strength of regularization is lower C and higher C. In lower C, it adjusts to the majority of data points, whereas in higher C, the correct classification of each data point must be correct, or as close as possible. And C is equal to 1. So let's use some of this regularization to modify some of the parameters to see if we can get an even more efficient prediction. So let's go ahead and run that. And our accuracy as far as the training has in fact improved. Both the training and test subset are at 97%. So that was with a higher C. Let's try it with a lower C. We'll just do that just by changing this. 0.01 and run it. And that drops it down to 93% with the lower C. So obviously it would be best to use the higher C for this logistic regression. So now let's get a look at this linear regression model. We'll import mglearn to get a better look. So we'll run it. And this is a look at our model. You'll see the training data, the linear line. These are the weights, and these are the biases. So that will conclude our theory on logistic regression. We will also be using logistic regression with Apple's Accelerate when we build our neural networks in this course. See you in the next lesson.